Okay, so today we're going to be piggybacking off of our last set of notes on implicit derivatives. Okay, so implicit differentiation is basically chain rule. Okay, it's when you're taking the derivative with respect to one variable and the variables don't match. So you have to do chain rule. So for instance, this equation right here is the equation of a circle. X squared plus y squared equals 9. Now you could rewrite this as y equals the square root of 9 minus x squared and take the derivative explicitly. Okay, and we'll talk about why that doesn't necessarily work so well in just a minute. Okay, so we're going to take this derivative implicitly. So I'm taking the derivative of both sides with respect to x. Okay, so the derivative of x squared is 2x plus the derivative of y squared, which is 2y dy over dx equals 0. Okay, and once you have your derivative, you solve for dy over dx. So we subtract 2x from both sides, so we get 2y dy over dx equals negative 2x. Then we divide both sides by 2y, and we get dy over dx equals negative x over y. Okay. Now, if we had done this way and done it as the square root of 9 minus x squared, we would have, one, had to remember that there's a plus or minus there. Because when you take the square root of a square, it could be positive or negative. Because if you just have the positive one, you get the top half of my circle. If you use the negative one, you get the bottom half. But when you take the derivative and you get dy over dx, you're going to get negative 2x on top and 2 square root of 9 minus x squared on the bottom. Okay? And again, there's going to be kind of like a plus or minus deal that you're going to have to deal with. Now, two things show up. Okay? Basically, the implicit derivative is much easier to deal with. Negative x over y is much easier to plug in and find slopes that way. And this one, like I said, you've got to deal with the square root on the bottom, and you got to deal with the fact that you can't have any negative numbers coming out of this. So basically, you've got to figure out where your positive ones are, where your negative ones are, and it causes quite a bit of a headache. Okay? But that's why sometimes it's easier just to do the implicit. All right, so again, we're going to do this one implicitly. So we take the derivative of both sides with respect to x. Okay, so the derivative of x cubed is 3x squared minus, we have the derivative of x times y, which is going to be, I put in parentheses here because I have this minus, so it's going to be y plus x dy over dx, because we have to do product rule. So the derivative of x is 1, the derivative of y is dy over dx, plus the derivative of y squared, just like we did over there, is 2y dy over dx equals to 0, because the derivative of 7 is 0. Okay, and now the reason I put the negative in like this in parentheses is because we have to distribute it in. So we get 3x squared minus y minus x dy over dx plus 2y dy over dx. So what I'm going to do first is anything that doesn't have a dy over dx, I'm going to move it to the right side. Okay? So the 3x squared and the negative y, move it to the other side. I'm also going to switch the 2y, or you can see here that both of these two things have a factor of dy over dx. So I'm going to factor dy over dx out. And I'm going to get 2y minus x equals y minus 3x squared. So I moved this to the other side, and then I factored out my dy over dx. And then the last step is to get dy over dx by itself by dividing both sides by 2y minus x. So you get y minus 3x squared over 2y minus x, like that. And that's your implicit derivative. Okay. All right. The last example. So again, taking derivative of both sides with respect to x. Derivative of sine x is cosine x plus 2. And now we're taking the derivative of cosine 2y, which means I'm doing chain rule. So the derivative of 2y is 2 dy over dx times the derivative of cosine, which is negative sine 2y, equals 0, because the derivative of 1 is 0. Now, again, we're going to move, or I guess we should simplify this a little bit first. So we get cosine x, and then this should be, it'll be easier just to put negative, because you have 2 times negative sine 2y, so it's negative 4 sine 2y dy over dx equals 0. So since this is negative, I'll move that one to the other side. So you get cosine x equals 4 sine 2y dy over dx. And then divide both sides by 4 sine 2y. 4 sine 2y. So we get dy over dx equals cosine x over 4 sine of 2y. And that is our implicit derivative. All right. The last problem is on finding the slope of a curve. Okay, so remember, slope is nothing more than the derivative. So it's asking us to find the slope at that point, or it's basically asking us to find the derivative and plug in those values to find the slope there. Okay, that means we're just got to do this implicitly. Okay, so again, derivative of all of this with respect to x. So we get 3y squared dy over dx minus 2x equals 0. So dy over dx equals, you move the 2x over, it becomes positive 2x divided by 3y squared. So that is our derivative. Now we need to find dy over dx at 2, which means we plug in 2 for x and 2 for y. So 2 times 2 over 3 times 2 squared, which is 4 over, that's 4 times 3 is 12, which is 1/3. So my slope, m, at 2, is 1/3. And that's our answer. So we're basically doing all the same stuff that we've been doing before with derivatives, using the same rules. The only added difference is that when we're taking the derivative with something with y in it, we have to do it implicitly using chain rule, and we get this extra dy over dx in it. And then everything else just is exactly the same.